Okay, today we are going to discuss more on science and civilizations in Anatolia and Islamic world and Greek world and European in later times, passing Hellenistic era. We will start going into early to Middle Ages. That is called as post-classical science and Middle Ages. In the in those years, post-classical science, after Hellenistic time, after Egyptian time, Greeks, names Byzantine Empire, Arabs and Latin civilizations have seen developments. In addition to this, there was a Chinese civilization as well. Starting from Anatolia and the remnants of the remainings of the Hellenistic work, it was a form of classical science in Hellenistic times. It was connected with the early pagan philosophy and metaphysics. So it was science plus religion together. In those years, it was just after wasn't just after 400 years. Jesus was born, so it was after Christianity. But considering that Christianity and Bible have been written several hundred years later than Jesus' times, so it was about enlargement days of the Christianity, like 300, 400 years of AD was good years of Christianity. In the world, University of Constantinople, meaning University of Istanbul, was considered as the first university in the world. University was in the palace, University Palace, named as Magnaura Palace. It was an educational institution going back to 425 AD. Around 100 years before Hagia Sophia. Right? During Hagia Sophia, when Hagia Sophia was built in 530 AD, University of Constantinople in Magnaura Palace were in the place and it was functioning. Emperor Theodosius founded the university. It was also called as Pandidakterion in Old Greek. Maybe I should ask this to Zafarakis Hoca. He may have more understanding of the word Pandidakterion. At that time, 400 AD, different schools were also present. Economic schools, colleges, polytechnic schools, libraries, and fine art academies were operated in the city. The society was interestingly developed. Primary education was widely available, and it was even available at the village level, primary education. Both boys and girls. Female participation in the culture was very high. Scholarship meaning not money scholarship, but studying for studying. That is scholarship. Being scholar was fostered not only in Istanbul, but also in institutions operated in major cities in Byzantium Empire, such as Antioch and Alexandria was in Egypt. Antioch is in, where is it? Antakya. So there were institutions promoting studying and scholarship at university level. Original school was built by Emperor Theodosius with 31 I wouldn't say professors, they say chairs, 31 scholars for law, philosophy, medicine, arithmetic, geometry, and astronomy, music, rhetoric, talk and discussion, and other subjects. Latin and Greek scholars. That university existed until the 15th century, until the fall of Constantinople, fall of Istanbul, and until Fatih conquered Istanbul. However, fall of Istanbul, the decline in Istanbul started by 1204, when Latins invaded the city and destroyed. So after that destruction, many things were demolished and taken back to Europe. People left. Most of the scholars left Europe, left Istanbul to Europe and Egypt, etc. So city was turned into a poorer stage. Today, this is interesting. If you have time on the weekend, you can visit. That is the university building, saying Magnora Sarayı restorasyon inşaatı in Sultanahmet. There is a this is today's current situation in the university. You can visit in Google Maps, just say Magnora Sarayı. There is also Magnora Hotel next to it for tourists. They took their name from the palace. This was part of the palace, and that was the not entrance, but one of the doors of first university in the world. That is the place in Sultanahmet. There is cafe, of course. This is interesting. Okay. The main topic of higher education for most students was rhetoric, discussion. Learning to talk, learning to write, learning to read very well, and law, with the aim of producing competent, learned personnel to staff the bureaucratic postings of state and church. So to educate people for higher level of jobs. In that sense, university was secular equivalent of the theological schools. So they were not teaching for church, rather because church was not established as if it was in medieval times. in the early days of Christianity, probably similar to early days of Islam, it was not that strong on the science, so scientific work proceeded secularly at the beginning in all religions. So it was a secular equivalent of the theological schools, because the theological schools tries to promote and study why God is created and how to obey, etc. So standard procedure of praying and practicing. And they educate their people for that purpose. In this case, the purpose of the University of Constantinople was educate people for bureaucratic jobs rather than for priests. University maintained active philosophical tradition of Platonism and Aristotelianism, with the former, Platonism, being the longest unbroken Platonic school, running for close to 2,000 years until 15th century. So effect of Hellenistic work was still there, although Christianity is there. In terms of science and scientific thinking, Platonism and Aristotelianism were followed. The decline began with the Latin conquest of 1204. So most people left, although the university, as a university, survived as a non-secular institution because church improved over the years in the medieval times. So university survived as a non-secular institution under church management until the fall of Constantinople in 1453, and re-established by Fatih Sultan Mehmet as a medrese, as an Islamic theological school. So Fatih Sultan Mehmet didn't forget that, and they converted the school to Islamic theological school rather than Christian theological school. So it was still school. This was the view of Sultan Ahmet around 1204, before 1204. In front of Hagia Sophia, there were gates, and those gates, there were 4 horses, golden horses. Those golden horses were taken back to Italy along with other gold items in 1204 by Latin conquest. Today, they are there. Those horses are displayed in museum in Italy. There was a hippodrome and there was a place for horse racing. The university was on the right side of this. So it's behind Sultan Ahmet now. This is the remake of the city before 1204 Latin conquest. There was a big hippodrome. There was another area near Çemberli Taş. You know that, right? Çemberli Taş. The others are Dikili Taş, came from Egypt. The palace was, university was somewhere here. There is a big palace here. This is very important in Kumkapı. That palace was the king's palace, etc., emperor's palace, and there were ships going in and out. today there are fish sellers in that region, and Avrasya Tüneli was coming out at that point. The reason of delays in Avrasya Tüneli, in those excavations, you remember those excavations, Tabak Çanak, etc., were in that place, and that was very significant in the Byzantium. That's why it's delayed. This palace was also destroyed significantly around 1200. Today, again, I tried to find additional pictures of the university. Today, they are trying to restore it, and most sections were underground, buried, and there were rumors that one person who owns the area before year 2000, in Bedrettin Dalan's time, were sold those stones by excavating them with trucks. So probably looking for gold or something like that. They emptied most of the area. But these are the restored parts. This is for writing. In Byzantium Empire, people were good in mathematics, physics, medicine, weapons, like we know Greek fire were present, and some humanism and thinking. Don't get me wrong. I am not trying to say that the mathematics, physics, and medicine were highly sophisticated. In most cases, it is connected to pagan culture, Roman culture, before Christianity, right? And related to Christianity, more than half of the ideas were incorrect, but they were correct for those years. But still, there were people thinking about mathematics, physics, and medicine, and writing on those topics. And there was a university. That's why until 1204, Latin conquest, Istanbul was a very great place for science, and furthermore, it was probably the biggest city in the world in those years. Islamic science and Byzance were highly related. There are reasons for it. They were not always fighting, because in Anatolia there were Islamic people, in the Middle East there were Islamic people, Arabs, and later Turks. Turks were working for, some of them were Christian. Turks were working for Byzantium Empire as well. There were people, usually Turks, speaking both languages in the early times of Ottomans, after Alparslan, etc. There were Turks in Anatolia speaking Greek and speaking Arabic. So they helped to exchange ideas in between. They don't fight all the time. Okay, they fight from time to time. When I think about Byzantium Empire and Islamic people, to my age, we always remember Turkish films by Cüneyt Arkın and Kartal Tibet, etc. So the image of Byzantium Empire is always connected with those films. So there were always fight, etc. But there were also good connections. I mean, there were technical people, there were trade. Okay. Early Greek texts from Hellenistic times were preserved by the Greeks, and they moved back to Greece, moved back to Byzantium, and Islamic world first obtained those resources, such as Euclid's Elements, old books coming from Egypt, etc., from Byzantium Empire. So there were cultural exchange between Byzantium and Islamic people. The Islamic people were also exchanging information with China and India. So information taken from China and India, for example, numbering system, were transferred back to Byzantium Empire. So Byzantium Empire was kind of buffer in between later European development and Islamic world. Okay. Some scientists such as George Koinades some scholars like George Koinades visited Islamic observatories, translated books on Islamic astronomy to Greek. So some Islamic books were translated into Greek, some Greek books were translated into Arabic. So Arabic-Greek interaction was very significant. When, let's say, between years 800, 900, 1000, and until Fatih Sultan Mehmet's time. But as time progresses, like after 1400, church in Byzance and Europe was so strong, so they eliminated the progress of science. So most of the achievements were happened until Latin, maybe until 1300, 1300 years from Christ. 1300 yılına kadar. Byzantine science played an important role, not only transmitting ancient Greek knowledge to Western Europe and Islamic world, but also transmitting Arabic knowledge to Western Europe. So it was a gate from Arabic knowledge to European knowledge. Some historians believe that Copernic or other European author had access to Arabic astronomical text. There is an idea. So Copernic was following Arabic text. Some people say that, resulting transmission of the Tusi couple, an astronomical model developed by Nesir al-Din al-Tusi, that later appeared on the work of Copernic. So some people say that Copernic translated certain Arabic text and heliocentric ideas rather than geocentric ideas were the result of Islamic studies happened before. Scientists also became familiar with Sasani and Indian astronomy through citations in some Arabic works. So since Arabic people were also affected from Iranian, Chinese, and Indian texts, since they are translated, so scientists in Byzantium Empire were also affected from Eastern studies. After what happened in 1453? Fall of Istanbul. Western people say fall of Istanbul. Eastern people say gaining of Istanbul. So it is two-sided issue. They lost, we won. But actually, it's a big change. Number of Greek scholars went to Italy from Istanbul. They escaped. Some of them were escaped in Latin Inquisition. The remaining ones left the city after Fatih Sultan Mehmed occupied. And they were considered as a starting fuel of Renaissance in Italy, because Europe was in very bad shape. Italy has some trade ability for the world, so they were good in shipbuilding and trading, Italians. But in terms of culture, they were highly affected from people came from Istanbul in Renaissance. In terms of understanding medicine, zoology, and plant knowledge, botany. I am going to name some people now. One of the guys is Jabir ibn Hayyan. The Latin people, Europeans name them as Geber. He is known as first chemist known to produce sulfuric acid as well as many other chemicals and instruments in 700, 800 AD. They wrote on adding color to glass by adding small quantities of metallic oxides to glass, such as magnesium dioxide. So they are collected in a book named as Kitabül İstitmam. He also writes on nitric acid, which is very important in chemistry. So Geber is the worldwide known name for him. Khwarizmi is very famous. We have this picture in the other lab in the first floor. He developed algebra, Elcebir vel Kabele, calculus of resolution and juxtaposition. It is later referred as algebra. Yes, this is very famous guy, AlHindi. some of you may have heard if you are interested. He wrote on distillation of wine. Sorry. AlHindi. Writes on the distillation of wine as that rose water and gives 107 recipes for perfumes. Book of chemistry and perfumes and distillations. That is part of the book on the right. That is handwriting. He was the first major writer on optics since Hellenistic time, antiquity time. Then Roger Bacon, later scientist, placed him in the first rank after Ptolemy as the writer on optics. Ptolemy in the Hellenistic time and Egyptian antique time. AlHindi was the second after that in history. In the first page of manuscript, the topic says on deciphering of cryptographic messages, containing the oldest known description of cryptanalysis by frequency analysis. So he even did some cryptographic studies. They were very interested in mathematics and numeric number crunching by hand. He wrote, he's interesting. He wrote 260 books. And at that time, when we say book, it's actually notebook to write by hand. So he probably filled 260 notebooks for other people to read. Contributing heavily to geometry, 32 books on geometry, 22 books on medicine and philosophy, logic, 9 books, physics, 12 books. Most of the books have been lost over the centuries. Few have survived from the Latin translations by Gerard of Cremona, and others have been rediscovered in Arabic manuscripts later in excavations. Most importantly, 24 of his lost works were located in the mid-20th century in Turkish library. So they are available. AlHindi's work is available if you are interested. Unfortunately, as I said last time, these topics are so deep. It's not like learning C programming language. You have to read a lot. I mean, 24 books were found. So in order to understand the topic, you need to read 24 books. That is the idea. In little bit later, as I said, little bit, but 73, that's that. So little bit later is actually a lot of time. Book of Naphtha and Petroleum. They found petroleum, black matter, and how to distillate it, raffination. Kitab Sir al-Asrar, Book of Secrets. When choosing site to build Baghdad's hospital, they asked him to where is the best place for making the hospital. He hung pieces of fresh meat in different parts of the city. So checked how meat is getting bad. So the location where the meat took the longest to rot, longest to get bad, was the one to choose for building the hospital. So that was the experimental method of finding the best place for hospital building. He advocated that patients not be told their real condition so that fear or despair do not affect the healing process. That's also interesting. Tell lies to patients. You are good, so that they get better. It's also experimental. He worked on alkalis, soda, and soap, and glycerin in chemistry. Again, Book of Secrets was published. That book is available in 1925. 925, not 90. Tabit is interesting. Maybe name is kind of funny, so it is famous on the internet in Turkish people. Tabit ibn Qurra. He studied math in Baghdad under the rule of Banu Musa brothers. Banu Musa was the ruler. O kadar da iyi değilim. Probably in Emevi or Abbasi. 800 Abbasi, I think. Abbasi time. Tabit discovered a theorem that enables pairs of numbers to be found. So consecutive numbers, numbers coming after another. He studied number crunching again. Later, al-Baghdadi improved his theorems. Tabit was famous because he was from Haran. Today, he is very famous. It is either because the name is interesting or is from Haran. I have no idea. He translated certain things. They can read, write Latin. They can read like Greek. They can read, write other languages. So they are very good in translation. So it's one of the translation from Apollonius Conics. Tabit's handwriting. At that time, three systems of counting were used. Finger arithmetic, with numerals written entirely in words, used by business community. Hexadecimal system, used by Babylonians. And numerals indicated by Arabs, which is used for astronomical work, and Indian numerical system. Arithmetic requires dustboard for finger writing, because in most cases, in order to move quantities in formulas, they need to move symbols from one place to another. So reading, erasing, and moving things were developed in those years. Taking some variable from one side of the equation to another side, you need to erase this side and move to the other side. So that was developed. Hexadecimal system has 60 symbols. Today we have hexadecimal. How many symbols we have? 16. In the hexadecimal, it has 60 different symbols. You have to memorize it. So quantity of 45, for example, today's 45, has a symbol. this symbol. This symbol says, just making it up, 45. This is 46. So that is hexadecimal system. It originated with the ancient Sumerians in the 3rd millennium BC and passed down to ancient Babylonians, Sumerians to Babylonians, and today it is still, I said it, still used, because 1 minute is of 60 seconds. 1 hour is 60 minutes. So that is the result of hexadecimal system. Who else? Ebul Hasan el-Masudi, again chemistry. El-Uklidisi, modified arithmetic methods for the modified arithmetic methods for Indian numeral system to make it possible for pen and paper use. Doing calculations with Indian numerals necessitated the use of dustboard, as we said earlier in the previous slide. You need to erase and write, but with the improvement, with his improvements, that necessity was not longer there. So he probably invented replacement symbols for certain things. El-Buzjani, several treatises using finger counting system of arithmetic, was also an expert in Indian numeral system. Using Indian numeral system, he was able to extract roots. He was able to calculate roots of a number. El-Baghdadi, famous, studied slight variant of Tabit in Ibn Qurra's theorem on certain numbers. El-Baghdadi also wrote about and compared 3 systems of numbering and arithmetic system used in the region in that period. So 3 different numbering systems were present about year 1000. We are following years around 70 years later. It is a lot of time, 70 years later, and another generation. Persian Turkish mathematician and poet. He gave a complete classification of cubic equations with geometric solutions found by means of intersecting conic sections. Well, I don't understand that deeply. Cubic equations, I understand. Geometric solutions found by means of intersecting conic sections. It is difficult. He extracted roots using the decimal system. Decimal system is Indian system. Okay. Indians use decimal system. So he knew how to extract roots. He did study Euclid's elements. Euclid's elements postulates. The name of that is Risale fi Sarma min Müşerret Kitabi Euclidis. He finished that in 1077. Euclid's elements on proof of problems concerning algebra, 1079. He furthermore wrote a short book on extracting binomial theorem and the nth root of natural numbers, nth root, which has been lost. I don't have it. He refers that in other studies. Ömer Hayyam was kind of Iranian Turkish or Arab. He was given funding for making an observatory, astronomical observatory. Niye böyle bir astronomical observatory at Isfahan. He was given by Melik Shah to build an observatory to reform the Persian calendar. When you are a king, one of the biggest thing that you can achieve is playing with the calendar, so that your ruling will stay. Changing the calendar, playing with the calendar, declaring certain holidays, etc. So, or making errors correct, fixing existing errors, etc. So Melik Shah said, build an observatory. Ömer Hayyam a plus b to the n binomial theorem, where n is a positive integer. He was able to expand 1, 2, 2, 1, 1, 3, 3, 3, 1, etc. binomial theorem for polynomials. He was able to do that. The case of power 2 is explicitly stated in Euclid Elements, and the case of at most power 3 had been established by Indian mathematicians, but Hayyam was the mathematician who generalized the number n. His philosophic attitude toward life in Turkey, he is famous for that part. His philosophic attitude toward life as combination of pessimism, nihilism, Epicureanism, fatalism, and agnosticism were also interesting. He became an agnostic later in his life. El-İdrisi, El-Semavai, El-Tusi. These are also worked in algebra and mathematics. These are really important. As you see, there are a lot of Arabic, Persian scientific scholars in those years, before medieval times. When medieval times came, then scientific advancement declined after 1200 or so. El-Jazari, El-Farisi. El-Farisi was Tabit's, following Tabit's work. Factorization and combinatorics, permutation, combination, etc. Those type of things is combinatorics. El-Jazari described mechanical devices. He was kind of engineer. 80 of them were trick vessels of various kinds, along with instructions how to construct them. Finally, Ulu Bey was on the Turkish side later. Arabic part was declining. Ulu Bey was in Uzbekistan, made an in Samarkand. Not the problem, the special case for Ulu Bey is he was also Sultan. He was the king. So money was not an issue. He was a astronomer and mathematician. But the problem was, since he was very interested in science, he was probably a good guy. And later, he was overthrown and assassinated. He failed to establish power. So in order to rule the people, probably in those years, you need to be a bad person, I think. So he was overthrown and assassinated. El-Kashi, he contributed to development of decimal fractions, fractional parts. He studied numbers like pi. So not only for approximating algebraic numbers, but also for real numbers like pi number pi. His contribution to decimal fraction is so major, so important that for many years, he was considered as the inventor of fractional numbers. Point something. Although not the first to do so, El-Kashi gave an algorithm for calculating nth root, which is a special case of the methods given by many centuries later by Ruffini and Horner. Horner method. Do you remember Horner method? Okay, there is a Horner method for finding roots of a number. For example, square root of 5. And the teacher says, use Horner method for calculating square root of 5. And in the mathematical exam, you apply Horner rule and find the square root of 5. That was a special case developed by El-Kashi. Cassidy, I'm following these. Let's keep that in. Later, number of mathematicians, number of scientists in Islamic world declined, and there are very few. For example, in 17th century, Arabic mathematician Muhammad Bekir Yazdi discovered a pair of amicable numbers, which is jointly credited with Descartes. 18th century, empty, couldn't find anybody. So Islamic science began its decline in 12th and 13th century. 12th century means 1100. 12th and 13th century before Renaissance in Europe, and due some part because of the Mongol conquests, Moğol istilası, where libraries and observatories, hospitals and universities were destroyed. End of the Islamic Golden Age is marked by the destruction of intellectual center in Baghdad, the capital of Abbasi Caliphate, in 1258. So in Byzantium, 1204 was the end, basically. In the Islamic Golden Age was ended in 1258. So around in the mid 13th century, the Golden Age were finished. The conditions of those years were very different. So I should repeat that. The motivations of people were very different. Slavery were present, although it's not mentioned that much. Human life was very negligible. There were different parts in the society, so classes of people in the society. When you are thinking in terms of scientific advancement, you should always take this into consideration. The understanding of human life, understanding of religion, they were all different than today's. So something normal for those years is not normal for today. That's very important. This is another picture of Istanbul. Hippodrome is at the top. Ayasofya is on the right. Palace is at the back. Genelde İstanbul Arkeoloji Müzesi var orada işte şimdi. Genelde Sultanahmet'e gittiğinizde pek arkasına geçmezsiniz. Meydanda takılırsınız. Bilmiyorum. Nargile içeniniz vardır belki. İçmeyin de yani. Kafeler var. Dip tarafında da İstanbul Arkeoloji Müzesi var. Vakit bulursam şimdi arkasına da geçeceğim. Daha önce geçtim ama bu gözlerle geçmedim ben. Buralarda acayip şeyler var aslında. Şu bölge. Şurası zaten Topkapı Sarayı. Burası Gülhane. Ama şurada bazı yerler var. Orası rampa aşağı gidiyor. Oralar çok tarihi bölgeler olduğu söyleniyor. Şurada var. Sultanahmet Camisi var. Şimdi Sultanahmet'in arkasında biraz önce bahsettiğim işte Magnora Sarayı'nın kalıntıları burası. Saray, esas saray orada. Oralar epey tarih içeriyor. Kalanlar tabii. Kalmamış bir şey. Evet. Gidip orada duygulanabilirsin ancak. Hipodrom dikili taşı biliyorsun. O taş yerinde normalde. Onun etrafında dönüyorlar. Bunun duvarları şurada duvar olduğu söyleniyor. Meydanın dip tarafında duvar varmış. Zaten Arkeoloji Müzesi şurada bir yerde. Şurada bir duvar olduğu söyleniyor. Ben görmedim yani. Şu taş duruyor. Şurada Alman çeşmesi var. Diğer taş duruyor mu bilmiyorum. İki taş var mı orada? Kırık olabilir. Bir taş biliyorum. Burası. Orada Four Seasons Otel kurmuşlar. Gene aynı bölgede. O da şu sarayın olduğu yerde galiba. Şurada bir yerde bir Four Seasons Otel var. Bu da iyi. Şurası Ayasofya. Siz görmediniz. Niye? Evet diyorsunuz. Four Seasons Otel. Bu. İşte bu daha evvel bu Bizans'tan sonra yapılmış Four Seasons Otel aynı yerde. Daha önce burası hapishaneymiş. Uzun süre Osmanlı döneminde hapishane olarak. Bu resim çok iyi. Bu çok iyi. Yani. Bu harbiden iyi. Şu Kumkapı'daki saray var ya. Kumkapı'daki sarayın reconstruction'ı sağ üstte. Tamam mı? Onun 1900 yılında şu anda artık yok. Belki bir gecekondu falan vardır oralarda. Balıkçıların orada. Şu andaki durumu 1900'de çekilmiş, Osmanlı'nın son döneminde. Şu haldeymiş. Orası, bunları niye anlatıyor? Bilgiye. Şurası, burası. Burası da şurası. Şurası. Ve bu gerçekten fotoğraf diyor. Fotoğraf da bu boyama. Sonra bakarak yapılmış. Böyle oldu. Bukelon Sarayı bu. Şurası. Bu bugünkü fotoğrafı. Tabii kötü bir şey değil. Hayat değişiyor. Tabii dolmuş burası. Kule eskiden suyun dibi. Fotoğraf daha önce de işte burası. Alttaki gördüğünüz yerde sahil yolu. Evet. Şimdi şu evde bir öğrenci oturuyor mudur? Mavi ev. Okey. Bugünlük bu kadar.